control. It is also one of the oldest. But what is radar? Where did it come from? What is it used for in the air traffic control system? Radar stands for Radio Detection and Ranging. The technology dates back to 1904, when a primitive type of radar was developed in Germany for use on boats to prevent collisions in fog. The technology was refined over the years, and its military value was soon recognized. In the mid-1930s, the United Kingdom set up a network of radar stations along its coast, called Chain Home. This radar network was instrumental during the Battle of Britain early in World War II. It allowed for efficient use of the heavily outnumbered Royal Air Force, which could now be vectored to intercept specific threats. Instead of operating continuous fighter patrols, radar operators could provide fighter pilots with a target's location, altitude, speed, and direction of flight. Over the course of World War II, radar technology developed quite rapidly, eventually resulting in radar sets that were small enough to be carried aboard naval vessels and even aircraft. In addition to the development of radar technology, World War II resulted in huge leaps forward in aircraft design. They became faster, able to fly at higher altitudes, and able to carry more people and cargo. Most radar systems in use today are not fundamentally different from those that were in use by 1945. More recent technology, such as computers, has changed the way we process and display radar information, but the basic technology is the same now as it was in the late 1940s. Radar has two basic functions in the air traffic control world: airport surveillance radar, or ASR, and en route radar. Airport surveillance radar is used by both tower controllers and controllers in the Terminal Radar Approach Control, or TRACON. In the tower, ASR is used to locate aircraft within the tower's airspace. Some towers use the same type of radar display as the TRACON. Others use a type of scope called a bright, or a digital version of the same scope called a D-bright. The TRACON uses airport surveillance radar to provide services and control instructions to aircraft in the arrival or departure phases of flight. TRACONs typically control the airspace within a 35 to 40 nautical mile radius. Radar works by sending a radio signal from a rotating antenna. If that signal hits an object, a portion of the signal is reflected back to the antenna and appears as a blip on the radar display or scope. This is called primary radar, in that the only information provided about the target is its location relative to the radar antenna. On older scopes, the beam is sometimes depicted as a line that moves around the scope as the antenna rotates. In World War II, radar controllers had to calculate things such as target speeds manually, by using a grease pencil to mark the position of a target as it changed with each sweep of the radar, and then using a slide rule to calculate its speed. Today, air traffic control computers automatically calculate a target's ground speed and display it to controllers. This and other information displayed, along with the primary radar return, is called secondary radar. The advent of transponders and the Mode C function has allowed information such as altitude and squawk codes to be transmitted back to the radar site and depicted on a controller's radar display as secondary radar information. In order to receive secondary information, an aircraft must be equipped with the proper type of transponder, and the radar site must be equipped with a beacon interrogator. As the radar signal hits the aircraft, the transponder detects the signal and sends back its altitude information and transponder code. Data, such as aircraft call signs, used to be written on a slip of paper and put on a shrimp boat, which was physically placed on the scope next to its corresponding blip, and pushed along as the target's position changed. Radar stands for Radio Detection and Ranging. It works by sending a radio signal from a rotating antenna. If a signal hits an object, a portion of the signal is returned to the antenna and displayed as a blip on the radar scope. Radar technology dates back to the early 1900s and hasn't changed much since the late 1940s. Primary radar is simply the blip that the sweep detects. Secondary radar is information displayed along with the blip. Air traffic control radar systems provide secondary information, such as aircraft call signs and altitudes, squawk codes, and ground speeds. Altitude and squawk code information is supplied by an aircraft's transponder, which sends the information back to the receiver at the radar site. Radar has two basic uses in air traffic control. These are airport surveillance radar, or ASR, and en route center radar.